friends, welcome back to my channel. So chemistry first chapter today we are going to discuss about the second chapter, gas laws and mole concept. I hope that you have understood the first chapter thoroughly. Now this is our second chapter, gas laws and mole concept. In this chapter we have to learn many laws of gas and the different characteristics and properties of gas. So first, the main point you have to know is that compared to solids and liquids, gases have a lot of characteristic features. Solid and liquid abhekshittu gases ennu parayunnathu namukku kaanan pattatha oru matter aanengil polum oru state of matter aanengil povum, it has a lot of characteristic features. Now first we can look some statements or some features of gases. Okay, there are 6 points, we have to learn just 2 or 3 of them. Okay, first one, so first we can learn some properties. I think this is a little bit tough chapter compared to the first one, but the first portion of the chapter is very easy. The last portion is a little bit tough, but we can learn it easily. Okay, now anyway, the properties of the gases, there are 6 one. Each gas contains numerous minute molecules. Gas each gas, oro gas, it contains numerous minute molecules. Then when compared to the total volume of a gas, the real volume of a molecule is very less. We have gas molecules. When we compare the total volume of the gas, we take the total volume of the gas and then compare it to the volume of a molecule. There are numerous molecules. When we compare the volume of just one molecule to the total volume of gas, it's very less. Then the molecules of gas are in a state of rapid random motions in all directions. So, this gas in the molecules in a state the state of molecules in the gas is always in a rapid random motion in all directions. It moves very fastly and spreaded. It's very spreaded. It's spreaded and it moves in a very random motion, rapid motion to all directions. The fourth one is that as a result of this motion, this random motion, they collide with each other and also collide with the walls of the container. So, direction direction it just moves in a very random motion. So it collides with each other. It also collides with the walls of the container which kept it. This collision accounts for the pressure of gas. This collision is gas in the pressure. As the collision of molecules are perfectly elastic in nature, this collision is elastic. So there is no loss of energy. This collision, these molecules parasparam collide, walls collide, elastic, there is no loss of energy. Then there is no attraction between the gas molecules and the walls of the container. In a container, if these are the molecules of gases, there is no attraction between this molecule and the walls of the container. This wall molecule, there will be no attraction. Then we have to learn the volume of a gas, pressure of a gas and a temperature of gas. Before that we have to fill the table 2.1. Energy of gas molecules is very high, distance between the molecules is also very high, freedom of movement is also very high, but attractive force between the molecules is very less. These are the 4 main features of the gas. Now we can learn about the volume of gases. First point is volume of gas. What is volume? What is the meaning of volume? Or what is the definition of the volume? Volume is the space occupied by a substance. If this board is kept here, for example, if this board is kept here or this duster is kept here, the space in which this duster is occupied is known as the volume of this thing. Okay, so the volume means the space occupied by a substance. So now what will be the volume of the gas? Volume of a gas means it changes respectively. If the gas is kept in a container like this, for example, if the gas is kept in a container like this of 10 kg, 10 kg sustain cheyan pattuna oru vessel, if we keep the gas, our volume of the gas will be 10 kg itself. Now if I change the gas into another vessel of 5 kg or something, it will occupy that space. So volume of the gas will change respectively. It will be the volume of the container in which it is kept. Now next one we have to learn is pressure of the gas. These points are very easy. We can understand it easily. Second point is pressure. What is pressure? What is the pressure for gas? Pressure means force on unit area. That is the simple definition of pressure. Force per unit area. Now how can we find the force on unit area? Total force exerted on the surface by surface area. You can see that formula in the textbook. Just learn it. No problems will be asked based on this formula. Just learn it. Total force exerted on the surface by the surface area. Now what is pressure means? Force exerted by unit area is called pressure. What is pressure? Just write this point. Force exerted by unit area. Per unit area is known as or is called as pressure. Now the third point is temperature. Temperature. Okay. Temperature means is the average kinetic energy of molecules. What is temperature? Temperature is the average kinetic energy of molecules in a substance. With a substance, molecules in the average kinetic energy is temperature. So 3 points: volume, pressure and temperature. Just write a short note about these 3 points in your notebook. Okay, that's very easy. Now we have to learn some relations between volume and pressure, volume and temperature, and volume and the number of molecules. So, these 3 relations are studied. First, we can learn about volume and pressure. V for volume and P for pressure. Volume of pressure. This relation between volume and pressure was established or proposed by Robert Boyle. Robert Boyle was a British physicist and chemist. He established the relationship between volume and pressure, and this relation is known as Boyle's law. Now we can come to what is Boyle's law. At constant temperature, temperature constant angle, volume of a definite mass of gas is inversely proportional to its pressure. Volume will be inversely proportional to the pressure of a gas in a constant temperature. This is the only relation we have to learn about volume and pressure. In constant temperature, volume and pressure will be inversely proportional. And this relation was proposed by Robert Boyle. So this is known as Boyle's law. Now next one, volume and temperature. The relation between volume and temperature. Volume and temperature. This relation was proposed by Jacques Charles. He was a French scientist, Jacques Charles. That's why this relation is known as Charles' law. And what is Charles' law? At constant pressure. Later we have told that at a constant temperature. Here at constant pressure, the volume of a definite gas will be directly proportional to the temperature. In Kelvin scale, volume will be directly proportional to temperature. That is, V by T will be always a constant. K is a constant. V by T will be always a constant. This is what Charles' law defines. At constant pressure, volume will be directly proportional to temperature in Kelvin scale. That is, V by T will be always a constant. Next one, the relation between volume and number of molecules. Okay, number of molecules. There will be the molecules in a substance or in gas. Number of molecules, volume and number of molecules. This relation was proposed by Amedeo Avogadro, who was an Italian scientist. Amedeo Avogadro. And this relation is thus known as Avogadro's law, and this law says that at constant temperature and pressure, there are 2 things to be compared or dependent when we say this law. At constant temperature and pressure, the volume of a gas is directly proportional to the number of molecules. That is, V by number of molecules is a constant. So 3 points we have to learn. One is between V and P, volume and pressure. That is Boyle's law. Next, volume and temperature. That is Charles' law. And volume and number of molecules. That is Avogadro's law. volume and pressure means volume and at constant temperature. That point you should not forget it. Volume and pressure will be inversely proportional. At constant pressure, volume and temperature will be directly proportional. At constant temperature and pressure, volume and number of molecules will be directly proportional. So this is what we have learned in this class. First we have learned 6 main characteristics of a gas. Then we have learned what is volume, temperature and pressure, and also 3 relations. These relations മാത്രം പഠിച്ചാൽ മതി എന്താണെന്ന് തോന്നും. പിന്നെ the relation between volume and temperature, we can expect questions from that law. We can see a table in table 2.2. Okay, table 2.2 in page number 36 we can see a relation, that is if volume 546 and temperature is 273, we get V by T is equal to 2. Next again 600 the temperature will be 300 and again the V by T is 2. Next number 640 milliliter the temperature will be 320 K, then again the V by T is equal to 2. But next number fill 660 ml volume ആണെങ്കിൽ 330 Kelvin ആയിരിക്കും. Then what will be V by T? That will also be 2, because we had told that according to Charles' law, volume by temperature is always a constant. So all the answers above is 2. So here also we can fill it as 2. ഇങ്ങനത്തെ easy questions മാത്രമാണ് നമുക്ക് ഇതിൽ നിന്ന് പ്രതീക്ഷിക്കാൻ പറ്റുന്നത്. Now in next class I will tell you some instances or some certain instances where we can apply this laws. ചില സന്ദർഭങ്ങളിൽ laws apply ചെയ്യാൻ പറ്റുന്നത് ഏതൊക്കെയാണെന്ന് I will tell you in the next class. So we can conclude our class by telling the main points. The 6 major characteristics of gas: what is volume, what is pressure, what is temperature, relation between volume and pressure, relation between volume and temperature, and the relation between volume and number of molecules. That is Boyle's law, Charles' law and Avogadro's law. അപ്പോൾ എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടെങ്കിൽ കമൻറ്റ് ബോക്സിൽ ഇടുക. നെക്സ്റ്റ് വീഡിയോ അപ്ലോഡ് ചെയ്യുന്നതുവരെ എല്ലാവർക്കും ഗുഡ് ബൈ.